So in the movie Castaway, this guy's on a FedEx plane and they hit turbulence and a big storm and they go down, the plane goes down in the ocean and everybody dies but Tom Hanks, okay? It's an old movie. See it if you can. It's a good one. So after a while, he gets good at fishing. And those are my fish, okay? And he's standing up here. There's my basic person. He's got a lot of hair because he hasn't had a haircut in a while. He's got a beard. And he's got a spear in his hand, okay? And that spear, when he throws it, hits both fish and kills them both at the same time. Got it? Mm-hmm. Well, but because the fish were swimming in a parallel manner, they were in a parallel, they were swimming right on top of each other in the same direction, the spear is going to hit them at the same angle, okay? Because they were, and that's what we're talking about today. We're talking about parallel lines, which are the fish, and the spear that goes through both of the fish, which is the transversal. Got it? Mm-hmm. So there's your vocabulary for the day. Mm-hmm. So for this class, we're going to assume there's parallel lines everywhere we look. There is one problem that doesn't have parallel lines, and I'll address that in a minute when we get to that problem. We'll probably do that one together. But we're going to look at different types of angles that are formed by parallel lines in a transversal. Okay? So here we go. Two parallel lines. And a transversal. Let's be a little neater than that. Okay. Now, one way that they can tell you that the lines are parallel is they can name them with a little cursive L and M or something. And then they would tell you in the instructions, L is parallel to M. And that looks like a tall 11. That means that they're parallel. But the way I like to note my picture when I know the lines are parallel is I put an extra arrow in the two that are parallel. Then you know they're parallel. If you see that extra arrow, that's another way of knowing the two lines are parallel. When two lines are parallel, the spear is going to hit them in the same angle, right? Mm-hmm. So how many angles are formed by that spear and those two lines? Let's number them. There's eight angles. Let's do 1, 2, 3, 4, 5, 6, 7, and 8. Everybody see that? Mm-hmm. Let's look at the different kinds of angles that are talked about that are formed by the spear and the two parallel lines, okay? The transversal. So we've got interior angles. And the interior angles are the angles inside the two parallel lines. So who are the interior angles?
3, 4, 5, 6.
3, 4, 5, and 6. What do you think the next one is?
Exterior.
Oh my gosh, yes. Exterior angles.
Which is 1, 2, 7.
1, 2, 7, and 8. Very good. Okay, the alternate interior angles and vertical angles, which we've already learned about, are the two type of angles that show up the most on the SAT and ACT. So whenever you see the word parallel lines on the SAT and ACT, look for alternate interior angles because that might get you out of trouble. That might get you into the problem, okay? Alternate interior. They're on either side of the spear, kind of kitty quarter from each other. You see how the 3 is on the other side as the 6, and they're in a diagonal formation, okay? So alternate interior angles are very, very important. Now let's do, sure, alternate exterior. What do you think those are?
1, 8, and 7, 2.
1 and 8 and 7 and 2. Do you see that?
Yep.
On either side of the spear and on the outside, kitty corner from each other. So if you draw like a diagonal, you'll get those two. You'll spear those two. Everybody get that?
Yep.
Now we have another one that people forget to use, and that is corresponding. And corresponding angles are angles in the same position of the two intersections. Does everybody see here there's two intersections, this one and this one?
Yep.
Well, what angle is in the same position as angle 1 in the second one?
5.
1 and 5. Now somebody else. Give me another pair of corresponding. What about 2? 2 and 6. Somebody else. 3 and who?
7.
3 and 7. Somebody else. What about 4?
4 and 8.
4 and 8. Okay? Those are corresponding. Now let's look at them. 1 and 5, top left of their intersection. 2 and 6, top right of their intersection. 7 and 3, bottom left of their intersection. And 4 and 8, bottom right of their intersections. Okay? So there's something that we know about those. So same side interior or on the same side of the transversal, but on the inside of the parallel lines. So 3 and 5 and 4 and 6. Okay?
1 and 7?
No, those are
8 and 5.
8 and 5. Yeah. So let's start with 1. Who's vertical to 1?
4.
1 and 4. This table here, who's vertical to 2?
3.
That's not this table. This table here, who's vertical to 5? 5 and 8, very good. And who's vertical to 6? Who's vertical to 6? 7. When a spear hits two fish that are not swimming in a parallel manner, then there are no relationship between these angles. However, when the two lines are parallel, we do know some things. Interior angles, exterior angles, we don't know anything about them. But let's start here at alternate interior angles. Your alternate interior angles, 3 and 6 and 4 and 5, are going to be what? Are they going to be the same measure? Are they going to add up to something? What do you think? They are the same measure, so they are congruent when the lines are parallel. What about alternate exterior angles? They going to be the same or add up to something?
Don't they add up to 180?
Not alternate exterior.
Oh, no, they're going to be the same.
They're going to be the same also. And what about corresponding angles?
Add up to 180.
No.
They're same.
They're going to be congruent. Very good. And what about same side interior? Huh?
Probably based on how it's all been.
Nope. They're going to be supplementary.
Yeah, so okay, so those are the ones that I don't.
Mm-hmm. And the vertical angles, we all know that, right? Vertical angles are always what?
90. No.
What are vertical angles?
180. That's something.
Congruent, people. They're always equal. Angles that are across each other on an X are always equal. Okay? So let's look at this. If I give you the measurement of angle 1, and I know those two lines are parallel, even though I didn't draw them very parallel, I know they're parallel because they have two arrows, right? I can tell you the angle measure of all the other 7 because of this information right here. Let's go. It's a chain reaction. Let's say angle 3 is 70 degrees. What is angle 1 going to be? 110. Now you can go crazy. 110. The vertical is also 110, right? And these two big guys are 110 because they're corresponding 4 is corresponding to 8, and 1 is corresponding, and then the other ones are all 70. So once I give you 1, you can find all of them. Okay, in this case, I have stealth zoom mode. All right, I have 2 sets of parallel lines. So I've got like 2 sets of spheres and 2 sets of parallel lines, and they work in both directions. So in this case, all of these are going to be the same. So if I gave you 1 measurement, you can find all 16 angles.
Yep.
All the other 15. So let's say this is 120.
Which one?
That one right there.
So it'd be 60.
Then the little ones will be 60. Can you see that 120 is bigger than 60? It's an obtuse angle. So all the obtuse angles are going to be equal.
All 120.
They're all 120. And all the 60s are going to be equal. All the little ones are going to be equal.
Yep.
Got it?
Yeah.
So I like putting tick marks on my picture, because then if it has a 2 tick mark, I'll say 60 is 2 tick marks and 120 is 1 tick mark. And if I ask you for any angle, this is a 2. If I ask you for any angle, you know what it is, and you don't have to keep thinking. You know, you can just kind of like let the problem take you there. All right? But what if I have this situation?
Well, they're gonna definitely touch.
No, it doesn't matter. Well,
In this case, I've got 2 spheres hitting the parallel lines at different angles. So let's say this angle here is 150. I have to know one of the blue angles in order to solve that one over there. Okay? So let's say the blue angle is 40 right there. So on the 150, make that 40. On the 150, what is its other angle? What are the small angles going to be? 30. I keep doing this. Let's stay red. 30, 30. Here's your small. And 150, and 150, and 150. But on the other sphere, what are the 2 numbers I'm going to be dealing with?
40 and 140.
40 and 140, right? And it is what it is. You cannot cross-contaminate those because the spheres did not hit at the same angle. So you have to have information about both. If they happen to tell you that the small angle on the blue side was 30, then they did hit at the same angle. But they have to tell you something. You cannot make that conclusion on your own. Since these 2 lines are not parallel, you can still name alternate interior angles and corresponding angles and alternate exterior and all those. You just can't say they're congruent. You understand that? And you can't say that you can say a linear pair adds up to 180. You can say vertical angles are always congruent. Vertical angles are always congruent. And then a linear pair always adds up to 180. But if I'm looking at corresponding, this guy here is not equal to this guy here. These 2 are not equal to each other. Okay? Because the 2 lines aren't parallel. In order for you to be able to say 2 lines are parallel, 2 lines are congruent, they have to be parallel lines. Got it?